Hey, Mr. Simone again. This is going to be part two of solving systems using elimination. For this video, we're going to look at some scenarios where we can't really identify variables that are going to be eliminated from the start. Okay, we're going to have to manipulate one of the equations to help us solve the system. Some really good things is that both of our sets of our problems here are written in that ax plus b y equals c form, so all in standard form, which is really going to help us solve the system. So let's kind of get started. What I like to do is when I see systems or I'm solving systems using elimination, I often want to look for values that line up where one is positive and one is negative, because I know that if I can make them look alike, I know that they will eliminate. Okay, so in this problem, I'm going to start by trying to get this negative x to look like negative 2x. Okay, the way to do that is you're going to have to multiply your equation, both sides of the equation, by the same number, which you can do. We know that from solving equations. So here, I'm actually going to start off by multiplying both sides by positive 2. All right, and what will happen is I will end up getting that negative 2x, which we can do. Okay, the key thing here is whatever you do to one side, you have to do to the other. Many times students will make the mistake here, they'll never actually multiply a value on the other side. Now when solving these systems, you can multiply on both sides, multiply by fractions, you can divide on both sides, which is kind of the same idea. But here, a nice easy thing to do is multiply by 2. I'm going to write this equation transformed right underneath it to just kind of keep the systems all together. All right, so I end up with negative 2x, because again that 2 times that negative x, which is actually that negative 1x, and then 2 times 2y, I'm going to end up with 4y. On this side, the 2 times that negative 13, I'm going to end up with negative 26. And sometimes what I like to do is either box it in or just kind of draw a line just so I can clearly see the transformed equation along with the original to help me solve the system. Now we can solve using elimination. Again, add vertically. The x's will eliminate, leaving me with my y's to deal with. Add these vertically. 3 plus 4y is 7y. And my constants, I got my 12 and that negative 26, and by adding them, you end up with a negative 14. Solving for y, divide both sides by 7. You're going to get y equals negative 2. Okay. Once you solve for one of the variables, you're going to want to solve for the other, and you get to decide on which equation you use. You can actually use any of the 3 equations you'd like. For this one, I'm going to use the second one, the one we didn't actually manipulate. So I'm going to rewrite that equation, 2x plus 3y equals 12. Take that y answer I got, which is negative 2, and plug it into the equation. You get 2x plus 3 times that negative 2 equals 12. And once you do that, you just solve for x. Okay? You get 2x minus 6 equals 12. We're going to add 6 to both sides of our equation to get 2x equals 18. Our last step in this problem is to divide both sides by 2. And we're going to end up with x is equal to 9. Once you have both variables, your x and your y, then you're going to write your final answer as an ordered pair. Just make sure you write it as x, which was 9, and our y, which is negative 2. That is the solution to our system. Okay? Some common mistakes, I think I said it before, but making sure that when you solve for the variable, you substitute it for the correct variable here. And also when you write your final answer, always write it as x and then comma y. So 9 and then negative 2 in this case. Now let's take a look at the second one. The second equation, we have a couple options. You could actually manipulate both equations here to kind of get your x's to eliminate. But sometimes trying to figure out numbers that they both go into can be a little bit large here. And then the second set, all right, you'll notice that we have a positive 6y on top and a negative 3 on the y on the bottom. That might be something I want to focus on because I know that I can multiply or manipulate the bottom equation to help me get that negative 6 to eliminate. So you have options when you're solving with elimination. Some are more efficient than others, but there are different methods for all of it. So for this one, we're going to actually try to get rid of the y's. You could multiply the whole top by 1/2 or divide by 2. But again, my suggestion is always try to multiply by an integer, a whole number integer, to help you with this. So for this one, just like the first example, we're going to multiply by 2 on both sides. You're going to end up with 12x minus 6y equal, don't forget about the other side, equal to negative 6. Now, if this happens where you kind of transform that second equation, my suggestion would be to rewrite the top equation just underneath the one that you transformed. So I'm going to rewrite the first equation, that negative 5x plus 6y equals 41, just underneath the equation that we changed. Again, I like to try to draw that line to show the divide so I don't get confused too much from here. Next step, add vertically. All right, 12x plus that negative 5x is going to give me 7x. The 6's are going to eliminate, is what we wanted to happen. Negative 6 plus 41 is going to give me that 35. And then we just solve for x. Divide both sides by 7. X is equal to 5. And like we had in the first example, you can choose any of the equations to substitute in to solve for your y. For this one, I'm going to use the top one, or the one that we rewrote here. So I'm going to rewrite the negative 5x plus 6y equals 41. Substitute in that x, which is what we got, that 5 in for x. Negative 5 times 5 plus 6y equals 41. And then we can just solve it. Negative 25 plus 6y equals 41. We're going to try to get rid of that negative 25 by adding it to both sides. So we're going to add 25 to both sides. You get 6y is equal to 66. Again, 41 plus 25 is 66. And then the last step is to divide by 6 on both sides. And we get y equals 11. All right. We have our x, we have our y. We now can write our answer as an ordered pair. And for this one, it is going to be 5, 11. X and then y. Okay. I hope this video kind of helps. Again, these are the systems when solving using elimination that you're going to have to manipulate the equation a little bit. There are times you have to multiply or transform both equations. Other times, they're a little bit easier where you want to try to isolate one of the variables, one being negative, one being positive, and try to, work with it. But there's no one right way to find the solution, but there are some more efficient strategies. My key is try to multiply by a whole number integer. Try not to multiply by a fraction, which is the same thing as dividing. You might find yourself getting a little bit screwed up. So best of luck. Keep watching. There's going to be another video after this for special cases. All right, keep working.